Hi, in this video we'll be learning about the law of cosines. Like the law of sines, the law of cosines is something that you use to find missing sides or missing angles in non-right triangles. Okay, so let's look at a couple of different types of triangles. The two on the left here, the side angle side and the side 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 triangles, those are two cases where you would use law of cosines. So for example, let's say you had two sides and an angle. So maybe you knew this side was 5 and this side was 11 and you knew this angle was 40 degrees. Okay, notice that you don't have an angle across from a side in any way you go. So this would be one case where you would use law of cosines. Another case would be if you had side, side, side. So let's say this side was 4 and this side was 12 and this side was 13. Again, there aren't any angles that we know, so you don't have any angles across from any sides, so you can't use law of sines. So that would be where you would use law of cosines. Angle, 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 though, is a little bit different. In the case of angle, 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 just because you know the three angles, let's say, remember they have to add to 180, but let's say you knew these three angles. Maybe this one was 20, and this one was 60, and this one was 100. The sides could be any size, because remember with if you know three sides, it doesn't really tell you that the side angles or three angles, the three sides could really be any size, because you could have the same three angles and just blow up or shrink down the same triangle. Okay, so again, at the top here it says you can't use law of sines on these. If possible, you'd rather use a law of sines, because as you'll see, it's a much easier formula. But you have to have a side across from an angle, and in these cases we don't have that. We don't know any sides across from any angles. Okay, here's the formula. The formula is actually three different formulas, and it's a little bit harder to memorize than law of sines. But if you take a look at it, there is something you can do to kind of help you to memorize it. Notice that on the left side, that's where you have the side lengths. So if you're looking for side C, then you would use the first formula. If you're looking for side B, you'd use the second formula. And if you're looking for side A, you'd use the third formula, because those are the ones that have the small c, the small b, and the small a. Also, if you're looking for an angle, you can use these formulas, and you can see on the right side of the formula where you have capital C, capital B, and capital A. So depending on which angle you're looking for, that would determine which formula to use. Also notice that the one that starts out with a small c squared is the one that has the capital C at the end of the formula. In the middle, you have the other two sides squared, added together, and then minus 2, and then those other two sides again, and then cosine of the capital letter that's the same as the first letter. So with b squared, you have the other two letters, a and c, so you have a squared plus c squared, then minus 2, and then those same two letters, ac, and then cosine of the same capital letter that the small letter was at the beginning. Okay, and same thing with the third one. But again, a little bit harder to memorize. Okay, here's an example of a problem. So in this problem, we're supposed to solve this triangle, and it says we're given a side B, a side C, and an angle A. So if we fill those three things in, remember we need to make our own triangle and draw a picture. And in the case of the right triangles, remember we always wanted to have the capital C at the right angle. In this case, it doesn't matter. So just name the angles A, B, and C in whichever order you prefer. But remember that the small a goes across from the capital A, and the small b goes across from the capital B, and the small c across from the capital C. So that's why the 1 is across from the capital B, and the 3 is across from the capital C. Okay, now that we have this problem, notice that if we wanted to do law of sines, we couldn't really do it, because when we set up law of sines, you have to have an angle and a side for one of your two fractions to know the numbers. and we don't have that. We can't go sine 80 over a number. And we don't even know these other angles. So one of our two fractions, when we do law of sines, you have to have an angle across from a side. And we don't have that. And so for that reason, we're going to have to use law of cosines. In this case, we're going to work on finding small letter a right away. And the reason why is because we know angle A. So if we know one of the angles, that would be a good place to start with whatever that capital letter is, because we'd be able to fill in that spot in the formula. Okay, so again, this is the way we memorize the formula again. So you have the side squared equals, and then you have the other two sides squared added together, and then minus 2, and then those same two other sides, and then cosine of the same capital letter that the first letter was. Okay, so let's actually solve the problem now. Okay, here's our formula again. And so what we're going to do is plug in everything we know. And so what we know is we're looking for a small a, so we've got a squared equals. B squared would be 1 squared plus c squared would be 3 squared. Because remember, the 1 was across from the capital B, so that was small b, and the 3 was across from the capital C, so that's small c. So 1 squared plus 3 squared minus 2 times 1 times 3 cosine 80 degrees. Okay, so if I simplify this a bit, this would be 1 squared plus 9, so 1 plus 9 minus 2 times 1 times 3, so minus 6 cosine 80 degrees equals a squared. Okay, so this is going to be 10 minus, and then on my calculator, if I do 6 times cosine 80, actually you could put this all in your calculator at once, but 6 times cosine 80 on my calculator gives me 1.04188. So the right side turns into 10 minus 1.04188, 8.95812 equals a squared. So now we'll square root both sides. And you get 2.99. So about 3. Remember, this might not be drawn to scale. Okay, so we have 2.99. Okay, and here's how we set up the formula. Okay, so now we know another side. So now we know 2.99 is where the blue dot is on this. So if I write 2.99 in there. Okay, now I'm going to try to find another angle. It says we have all the sides now, but how can we find an angle? Now we have an angle and a side across from it because we have the 80 degrees across from the 2.99. So now we can use law of sines. So we can go sine 80 over 2.99 equals, let's say we want to find sine beta over 1. Okay, so we're going to do cross multiply and divide. So we're going to take sine 80 times 1 on your calculator and divide it by 2.99. And you get a really small number. you get 0.33. Okay, but we're not quite done yet, because remember, that's not your answer. That's what sine beta equals. So sine beta equals 0.3294, we'll call it. And so remember, now we have to go second sine 0.3294 to get the actual angle. So second sine 0.3294 gives you 19.2 degrees. So beta is 19.2 degrees. So now we know angle B is 19.2 degrees. And remember, we know, we also know both sides, or all three sides. Now we have two angles. Now we only have one angle left. And we don't have to do law of sines for this one, because remember, triangles add up to 180. So now we know beta, and to get the last side, which would be side C, we'll just take 80 plus 19.2, which is 99, and subtract that from 180, and we end up with 80.8 degrees. Okay, then we've solved the triangle. Now we've got all three sides and all three angles. Okay, here's another example. First thing you want to do is draw a picture. Again, it doesn't have to be drawn to scale. You notice the last one wasn't. And fill in what you know. In this case, we know the three sides, A, B, and C. So I put those across from the capital letters A, B, and C. Okay, this is a case where it's side, side, side. Okay, so we can't do law of sines. It would be nice if we could, because that's a lot easier formula, but we don't have any angles across from any sides. So how do we decide which angle to look for first? The rule you're supposed to use is, whatever the largest side is, always find the angle that's across from the largest side. So in this case, we're going to look for angle C, because it's across from the 9. So we're going to use this formula, the one that starts with little c squared. Again, the reason why we're going to use that one is because the one with the little c at the beginning is the one with the capital C at the end. And since we're looking for the capital C, this is the formula we want to use. Okay, so we're trying to find capital C. Okay, let's actually solve it now. So again, here's our formula. And since we have the little c squared, we're going to take the other two sides squared added together, minus 2 times those other two sides again, and then cosine of the same letter that we have at the beginning. Okay, so let's do the problem. So we're going to do c squared, which would be 9 squared, equals a squared plus b squared, 5 squared plus 8 squared, minus 2 times 5 times 8 times cosine of c, because we're looking for angle C. Now the ones where you're looking for an angle, these are really difficult. People always mess this up. The reason why is because they always want to do this whole part all at once and then put the cosine C after it. But if you remember the order of operations says you're supposed to multiply and divide before you add and subtract. So this piece over here has to be left alone. Okay, so only do this part together. You can take the rest of it, 81 equals 25 plus 64 minus, you can do those pieces separate, but then we're going to have 80 cosine C, and we have to leave the 80 separate from the 25 and the 64. So in other words, we can add the two together. These two can become 89, but don't subtract the 80 from the 89. It's not going to turn into 9 cosine C. We have to leave the 89 minus the 80 cosine C, and don't subtract the 89 minus the 80. You'll see what we'll do. Okay, so next step, we're trying to get the cosine C by itself. So we're going to subtract the 89 from both sides. And that's going to give us 81 minus 89 is negative 8 equals negative 80 cosine C. Now divide each side by negative 80. And 8 divided by 80, or negative 8 divided by 80, is 0.1. So we end up with 0.1 equals cosine C. Okay, so now I'm going to go second cosine 0.1. Second cosine 0.1 gives me 84.26 degrees. We'll call it 84.3 degrees. Okay, so that's how we got that angle. So now we have the 84.3 degrees. Okay, let me fill that in. Whoops, sorry about that. Let me go back. So 84.3 degrees is where we left off. Let's see. I wanted to go from this slide. Okay, here we go. So now we've got 84.3 degrees. Okay, now we've got an angle across from a side. So now we can use law of sines. So we can go sine 84.3 over 9 equals, let's go for b, so equals sine b over 8. So I'm going to cross multiply and divide. So I'm going to take sine 84.3 times 8 divided by 9, and I'm going to get 0.8845. So sine b equals 0.8845. Now if I go second sine 0.8845, I get 62.2 degrees. So that's that angle. And then to get the last angle, angle A, I'm just going to subtract from 180. So if I add 84.2 plus, or 84.3 plus the 62.2, that gives me 146.5. So 180 minus 146.5 is 33.5. So this last angle is 33.5 degrees. So now I have all three sides and all three angles, so the triangle's solved. Okay, so let us know if you have any other questions, and good luck.